The core revolutionary insight that Richard Feynman brought to the common misconception about electricity, often summarized as the electricity flows like water in a pipe model, was to dismantle the overly simplistic sequential narrative of electron drift and replace it with a breathtakingly fast field-driven orchestration governed by the laws of electromagnetism. The profound misunderstanding, which even many engineers and technicians hold, is that when you flip a switch, electrons from the power plant begin a slow, trudging journey through the wire to your lamp, pushing each other along like marbles in a tube until the first one finally arrives to light the bulb. Feynman, in his characteristic style of cutting to the heart of physics, revealed this as a deeply flawed picture that obscures the true, elegant mechanism. The critical point, which he elucidated with immense clarity in his Feynman Lectures on physics, is that the energy transfer in a circuit is not carried by the kinetic energy of individually marching electrons. Those conduction electrons, in fact, drift with an agonizingly slow average speed, the drift velocity, on the order of millimeters per second. If lighting a bulb depended on this snail's pace, you would wait hours or days for it to glow after flipping the switch. Instead, Feynman explained, what happens is that the switch closing completes a circuit, allowing an electromagnetic field to be established almost instantaneously through and around the entire circuit at a significant fraction of the speed of light. This field, propagating as a wave or disturbance along the wire, and more broadly through the space surrounding it, acts as an intermediary and the true carrier of energy. Imagine the wire not as a hollow pipe, but as a pre-filled, tightly packed line of marbles, the electrons. If you push a new marble into one end, a marble almost immediately pops out the other end, not because the first marble traveled the length, but because the push, the pressure wave, traveled through the entire column at the speed of sound in the material. In the electrical case, the push is the electromagnetic field. When the switch closes, the power source, like a battery, almost instantly rearranges the electric fields within and around the circuit. This field exerts a force on all the free electrons in the wire simultaneously, causing them to jiggle and nudge their neighbors in a vast, coordinated net drift. The energy that lights the bulb is not delivered by a specific electron that left the battery. It is delivered by the field, which conveys energy from the battery to the bulb through the empty space around the wires, guided by their geometry. The electrons themselves are merely the local movable charge carriers that allow the field to be established and sustained. They are more like a working fluid or a conveyor belt than a messenger. Feynman stressed that thinking in terms of fields, not particles, is essential to understanding phenomena like the speed of electrical signals, the behavior of antennas, which radiate energy into space with no wire at all, and even the fundamental nature of light, which is itself a self-propagating electromagnetic wave. He famously noted that trying to understand electricity and magnetism without the field concept is like trying to understand chess by only following the movements of a single pawn. You miss the grand strategy governing the entire board. This misconception matters deeply because it leads to fundamental errors in reasoning about how circuits actually work, why a light turns on seemingly instantly, why power can be transmitted over vast distances with alternating current, where electrons essentially oscillate back and forth, never reaching the appliance, and why signals in a computer chip travel at speeds utterly divorced from electron drift. By correcting this, Feynman didn't just offer a technical footnote, he opened a window into the deeper reality of physics, where invisible fields dancing through space are the primary actors, and the tangible matter we interact with, the wires, the switches, the light bulbs, are merely the stage upon which this faster, more fundamental dance of energy transfer occurs. It is a quintessential example of Feynman's genius. taking a familiar, seemingly settled concept and peeling back the layers to reveal a more beautiful, surprising, and truthful explanation rooted in the fundamental laws of nature, thereby transforming a mundane observation into a profound lesson about how the universe actually operates.